All right, guys, welcome to your first lesson, pre-recorded lesson. I'm just gonna hop right into it because I don't want to waste any time and make this video any longer than it needs to be. So without further ado, we're gonna hop right into 1.1.1, which is about functions. And I have a think slash a warm up here, and it says in a graph, which axis is for inputs and which axis is for outputs. And what I mean by that is in our standard graph, we have an x-axis and a y-axis, right? And typically when you're working like in a science class, it might be a little easier to see what I'm talking about. But in math, it's kind of the same thing. So normally we would pick an input. So we would pick x typically as an input. So the x-axis is for inputs. And then from that, we would get let's say we pick here on the graph, right? Where is that? And then we would get a y value, which is why we usually call them y values. That should sound familiar. So the y axis would be for outputs. And for these definitions, excuse me, for these definitions, I like to give the math definition first, like the mathy terms, and then I like to explain it after, just because I like to get that vocabulary in your head, and then usually once I explain it better, if you didn't understand the mathy definition, then you're like, oh yeah, okay, and then you make more connections with the super mathy terms. So a relationship between inputs and outputs is a function if is a big word. If there is exactly one output for each input, functions are often written as y equals and then some sort of expression with x, where x is the input and y is the output. So there again, we have x input and y is the output. And then we have the following table and graph represent the same function as the equation y equals, in parentheses, x minus 2 squared. Now, this is an equation because we have an equal sign. This table on the left shows the exact same thing, just in a different form, right? If we were to go through and plug in a bunch of x values, so let's plug in 1. What happens when we plug in 1? Then we get 1 minus 2, which is negative 1, and then square negative 1 is going to become a positive 1, right? Now, if we plug in 2, same thing, 2 minus 2 is 0, squared is going to get us 0. So if we did that for every point, that's why this table is just a representation of that equation. Likewise, this graph is just a representation of both the table and the equation, right? They're the same thing, just shown to you differently. So if you were to plot every single infinite point on a graph of this equation, that's what this graph would be. All right. And then just a couple more definitions that you might have already heard before. Extend the page just a little bit. So the set of possible input values for a function is called the domain. In layman's terms, that's just all the x's, right? In the above example, the domain of the function is all real numbers. So if we go up here, it's basically asking what x are we allowed to plug in, right? And we could plug in any x we want. That's not going to be a problem, right? This graph is probably the easiest way to see it. Even though we're going up like this, we can go outwards forever, right? We're never going to stop. So all real numbers just means we can plug in any of these x's. Now, the set of all possible output values for a function is called the range, which, in other words, is just all the y values that are possible. In the above example, the minimum value occurs at the vertex where y equals 0. So the range of the function is y has to be greater than or equal to 0. And to look at that one, so now we're looking at the range. Let's look at the range here. So the range is all the y's, right? Well, we see right here, it doesn't go below here, right? There's nothing down this way, no y's. But we can go, it looks like it's going to go up and up forever. So we have all the y's up there, right? So that's why the range, that's why for the range, we're going to say y has to be greater than or equal to 0, right? Because nothing below 0 is on the graph, but everything above 0 is on the graph. And it makes sense in the equation too, right? If we have something squared, is that ever going to be negative? No, right? So that's why we have no negatives in this range. Another way to write a function is with the notation f of x equals instead of y equals. And it's just, you call a function f and it has an output f of x. And to just, make that a little more simple for you guys, you can essentially just replace f of x with y. And you can call it anything, right? It could be g of x or h of x. But if we have the option to, we usually just write f of x because f function is just a little easier. But if you start dealing with multiple functions and you have to name them different things because they're not the same, then that's when we start using g of x and h of x. But we'll get to that later. And so for our example here, we have f of x equals x minus 2 in parentheses squared. Now, if we were to ask what is f of 5, that's how you read it, by the way, f of x, f of 5. So what is f of 5? And my trick here is just to think, well, we originally had this, right? So what is f of 5 asking? What does that mean? Well, notice we replaced x with 5, right? If we replace x with 5, I'm just going to do that on this right side too, right? So let's do that. So we have parentheses x. Oh, wait, I'm replacing x's with 5s, right? So 5 minus 2 squared, no more x's, so we're good. And then 5 minus 2 is 3 squared, and then 3 squared is 9. So then how we would read that is f of 5 equals 9. And the last side that we're going to do for like this introduction to this unit is we're going to give an example of something that isn't a function. So x squared plus y squared equals 1 is not a function. But why? So let's look at a table here, right? X and y. Let's plug in -1 for x and see what happens. When we do that, we're going to get -1 squared plus y squared equals 1. -1 squared is just 1 plus y squared equals 1. Well, we have 1 plus something equals 1. This something, this y squared, better be 0. And how's that going to happen if y is anything but 0, right? So y is going to equal 0 there. But let's try something else now. If x equals 0, now what are we going to have? We're going to have 0 squared plus y squared equals 1, which is the same thing as y squared. Or is a little uncalibrated down here. Scroll down just a bit. Y squared equals 1. And then you're like, oh, that's just 1, right? But wait, isn't there another option? If x is 0, this is still true. But can't y also be -1? Because -1 in parentheses squared is +1. And here's where our problem is, right? We have the same input, even though it's on two separate things of the graph. We have the same input, but we have two different outputs. Two different outputs for the same input. And that's our problem. So that's why it's not a function. And if we were to draw the graph of this, scroll up just a little bit. We're going to draw the graph of this. The graph of, just as a reminder, our function is, or not our function, but our equation is x squared plus y squared equals 1. That turns out to be a circle that I poorly drew where it's supposed to be 1 with a radius of 1. And it's more easily seen on the graph, right? Like, let's pick an x point. Let's just say we pick there, wherever it is. How many outputs does this one input have? We can go up. Oh, there's an output. Oh, but we can also go down, and there's another output. So a quick check if you have a graph, if you can draw a straight vertical line through it, and it hits at 2 points or more, then it is not a function. And that'll wrap it up for our first video. This one was just an introduction to the section, a lot of terminology.